Hello, I'm Paul Shannon. Today's short presentation is called Using the Coalesce and Coalesce functions in SAS. I'm going to demonstrate some practical examples of using two lesser known but very useful functions in base SAS. These are called the Coalesce and the Coalesce functions. Essentially, these two functions perform the same task. However, as with many functions in SAS, one function, the Coalesce function, is for use with numeric variables, and the Coalesce function is for use with character variables. As with all base SAS functions, these can be utilized either in a data step or within ProcSQL. In short, the Coalesce and Coalesce functions return the first non-missing value from a specified list of arguments as per the order of which those arguments are specified in the Coalesce function itself, rather than the order they may appear as columns in a program data vector. These functions allow you to specify variables, numeric constants, or missing values even as function arguments. Of course, these can be passed in as literals, variable names, or macro variables. In testing, I have been unable to find a limit to the number of arguments that the Coalesce and Coalesce functions can receive. SAS version 9.1.3 successfully ran the Coalesce functions with 1024 arguments specified. Okay, here are some very simple examples. Imagine that I have a data set that contains two numeric variables a and b. In this example, the data step Coalesce1 uses the Coalesce function to return the first non-missing value of the two variables a and b, or a constant of 0. Note here that the variable x will never be missing. Should both variables a and b contain missing values, then the Coalesce function will return the third parameter as the first non-missing value, of course a constant value of 0. I've also contained another data step here called noCoalesce1. This performs the same task but using if statements. This is here just to be clear about what the Coalesce function is actually doing. However, whilst it may be feasible to use if and else statements for comparing 2 or 3 variables here, the coding quickly becomes tedious when the number of variables increases, and therefore the Coalesce function becomes more and more valuable. Consider this example dataset. Here, patients in a clinical trial are required to visit their medical centre every month. The dates of each visit are recorded in variables visdt1 through to visdt10. The question here is, how do we obtain the first recorded visit for each patient? Easy, I hear you shout. We could use the code shown here to read the dataset and create a variable called firstVisitDT and set that variable equal to the value of the column visdt1. The problem, however, arises where some values of visdt1 are missing, and as such, so are the values of the variable firstVisitDT. Here, in this example, we use the Coalesce function to get us around the problem. By specifying the 10 visdt variables in order as parameters in the Coalesce function, if the column visdt1 contains a missing value, the Coalesce function will evaluate the next column as specified in its list of arguments. In this case, visdt2 will be evaluated, and so on until a non-missing value is found, or the function evaluates all arguments, in which case the function will return a missing value. Here you can see the output achieves the desired result. Particularly if we look at row 10, you'll see the column visdt1 contains a missing value, and as such, the Coalesce function evaluated and returned visdt2. We can further simplify the code in the Coalesce function by using any of the normal variable shortcuts associated with the data step. Here we use the colon as a wildcard, so the Coalesce function will evaluate all variables with a name starting with visdt. Here the variables are passed into the Coalesce function in the order they appear in the program data vector. We can also use enumerated variables. Here we can use a shortcut to pass a list of corresponding variables with a numeric suffix. These variables will be passed to the Coalesce function in their respective numeric order. Here we use a positional variable shortcut. In this example, the Coalesce function will receive the variables visdt1, visdt10, and any other variables in between those two variables as per the program data vector. Note, if there is a mixture of character and numeric variables between the variables specified, the dataset will throw an error. You can also specify variables as part of an array or as an entire array itself. One question you may be asking is why not simply use the min function to achieve the same result? Well, for this basic example you could. However, it's best to use the two functions alongside each other as they can complement each other quite well. If we consider the code in this slide, we'll create two datasets. Dataset named firstVisit will contain the variables minvis and cs_viz. These variables represent the first visit as calculated by the min and the coalesce functions respectively. However, if the two variables calculated by the min and the coalesce functions are not equal, the row is also outputted to a separate dataset named anomalies. We hope to see anomalies containing 0 rows. Sure enough, we have one record where visdt2 contains an earlier date than visdt1. We could ignore this anomaly and simply again use the min function. However, on closer inspection, it may not be that simple. The value shown in visdt1 in this example may have been written on a paper CRF or a paper survey incorrectly, or it could be a data entry error. Only using the min and the coalesce functions together will give the programmer the best ability to catch this type of mistake. Here is the relevant links to the SAS online documentation for the Coalesce and the Coalesce functions. Thank you.